Okay, hello students. Welcome back to the last sessions of this week. In the last sessions, we talk about the iterator components. We use iterator components to access elements stored in the containers. In these sessions, we will talk about the container classes. So let's begin. Container classes are different kinds of structures for holding data. List, queue, stack, they all host data but uses different data structures. And because container is a template class, it uses a type parameter. For example, list of int or double or custom class type. You have to specify the type for the container, just like we learned from the template class concepts. And as we learned in the previous sessions, different container classes have different kinds of iterators. One might have a bidirectional iterator, another one might just have a forward iterator. So each container has its own iterator. We learned that STL contains sequence and associative containers. Let's first talk about the sequential container. The sequential container arranges data into a list so that there is a first element, second element, and next element, and so forth up to the last element. Linked list is an example of sequential container. Each element points to the next element. This diagram represents the linked list data structure. This is the first element. This is the second element, and this is the third element. The first element points to the second element, and the second element points to the third element. So that's what linked list is. Since this is not a data structure class, I'm not going into too much details about linked list. You will learn linked list in detail in the data structure classes. Today, just aware that linked list is a sequential container in STL. And the linked list can be singly linked list and doubly linked list. STL only has a doubly linked list, not singly linked list. So if you declare the list class, it is work as a doubly linked list. This diagram shows the differences between singly linked list and doubly linked list. Each of these nodes in the linked list is an element. So this node, they are all elements. Same for this one. So this is the first element, and this is the second element, and so on. And we learned that in the previous sessions, the begin member function returns the iterator points to the first element. So this begin member functions points here because this is the first element. In the singly linked list, there is only one link from one element to the another element. So there is one arrow here. There's one link. But in doubly linked list, there are two links, two arrows here, so that we can move forward and backwards. That is the difference between singly and doubly linked list. In singly linked list, because there is only one arrow, we can only go forward. But in doubly linked list, because there is two arrows, we can go forward and backward. Anyway, I'm not here to teach you the data structure. Just remember that linked list is a sequential container class in STL. This is the example code show how to use a list container. So let's run this code in terminal. List. So let me first compile this program. Compile as well. Okay, this is the output of this program. Let me make this a bit smaller. So here we declare the list container. The base type is int. So this list container stores the value of type int. First of all, just like a vector, we use a pushback member functions to store new elements into this container. So we are storing 1, 2, 3 values into this container using this for loop. And here we are declaring the iterator for this list container. So we put iterator, and just like a vector, we use a begin and end member functions to use an iterator to cycle the elements stored in the container. So this is a container. And we use a dereferencing operator to access the value of the elements. So here it prints 1, 2, 3 because we stored 1, 2, 3 here. And here we also cycles elements stored in this container using an iterator. And this time we are updating the value of each element to 0. And after these iterations, we are printing the elements stored in the iterator again. This time, the value is 0 because we update 0 here. So this is how you use a list iterator, list container. And note that the type of the iterator is different to the iterator used for the vector. So for vector container, the iterator type is this. So these two are different. So that is the reason why we are saying that each container has its own iterator type. And do you notice something here in this code? And 1 second, let me show you this one as well. So this one is iterator because here, and we use square bracket notations to access the elements stored in the container. So this one try to access the third element. Do you think this works? We learned that this is the random access because we try to access the third element in one step, not going through for loop. If I compile this program, compilers complain about this one because unlike a vector, the iterator of the list is not a random access iterator. So vectors iterator is a random access iterator, but the list containers iterator is not a random access iterator. It is a bidirectional iterators. So because of that, for list, we can use this. We can use decrement operator, and we can use the referencing operator, but we cannot use a random access operations using this square bracket. So we cannot do this because this iterator is not a random access iterator. It's bidirectional iterator. So that's one thing I would like to introduce you. And another one, do you notice anything in this code? We used the vector before. Compare this code with a vector. In the previous sessions, when we were talking about the iterator components, I said that iterator components provide consistent interface across different container classes. So I said that each container has its own iterator type. So vector has a different iterator type compared to this iterators for list. For vector, we use this one, not this type. But that is the only different things. So for example, if I just change this list to vector, for example, if I just change to this list to vector, and for this one as well, list to the vector, this code compiles well and works properly. Don't you think this is amazing? Let me compile this program. It compiles well, and if I run it, the program's output is correct. I changed the list to vector, but it works well. That's because iterator provides the consistent interface. Regardless of whether iterator is from the list container or vector container, because iterator provides the consistent interface, we can use the same syntax for list container and vector containers iterators. So this begin, and this dereferencing operator and increment operators, all this works with both list and vectors. And it's not just for them. Or other containers also uses a similar syntax because iterator provides the consistent interface. So this is the power of consistent interface. You can use the same code, or you need to do is just changing this container name. Okay, so let's go back to the slides. So this is the demo code we just saw in terminal, and I also said that the iterator for list container is bidirectional iterator, not a random access iterator. So this is illegal. Okay, so far we talked about the sequential containers. Now let's talk about another types of container, associative container. The associative containers are simple database or dictionary because each data item has an associate with value known as a key. For example, if the data is struct with an employee record, the key can be employee's social security number. And in associative container, the data can be retrieved based on key. Set template class is the simplest associative container. It stores elements without repetitions. So this means that there is no duplicate elements. Each element is its own key. And using set, you can add, delete elements, and you can also ask if an element is in the set or not. The set template class was developed with efficiency in mind. To work efficiently, set stores elements in sorted order. You can specify the order used for sorting elements as shown here, this syntax. So you specify order here. This is the concrete examples. You can use a greater, or you can use your own ordering method to sort the elements in the set. In any case, the ordering specified here should be well behave with a given type of values here. So this specified ordering method should work well with specified type here, in this case int. If no ordering is given, then this relational operator will be used to sort the elements. This is the example code of using a set. Let's run this code in terminal. So this is the output of this program. This time we are declaring the set container. And using this insert member function, we are adding 1, 2, 3, 4, 5, 6. 6 elements to this container, set container. And here, just like a vector and list, we are using an iterator to access all the elements stored in this container, set container, and prints it. set is also use a begin and end member function. The iterator provides a consistent interface. So they use a similar syntax. Here it prints A, B, C, D. Do you notice something here? We inserted 1, 2, 3, 4, 5, 6. We inserted 6 elements, but here it only prints the 4 elements. Why is that? That's because the set container does not allow to duplicate elements. So here D, D, C, C are duplicated. So this one and this one is not sorted. So that is the reason why there is only 4 elements. And do you also notice something else here? Anything else? If you look at this insert order, we added A first, D, C, B. So we inserted the elements in A, D, C, B, this order. But if you look at this output of this program, the order is different. The order is not A, D, C, B, but A, B, C, D. It is sorted automatically. So that is the reason why I said that set sorted elements. Set is a sorted container. And here set contains C. Using these find member functions, it checks whether this container contains this value, this character C. Here, because there is a C, the output is yes, which is expected. And we can also remove the elements using this erase member function. So this time, here we erase the element C. And after that, we print all the elements stored in this container. And because we removed C here, previously it prints the 4 elements, now it prints the 3 elements without C. So C is removed. And after that, we check whether C is in this container using these find member functions. And because we removed C here, the output should be no, and as expected, the program's output is no, which is expected result. So this is how you use a set. So there is 3 things you have to notice here. No duplicate elements stored in the set, and the elements are ordered. And you can use our find and erase member functions to check whether elements exist in the set, and erase means remove the element, remove a particular element from the set. And just like a vector and list, you can use a consistent way. You can use an iterator using a consistent way, similar syntax, beginning and end, and use this increment and dereferencing operator. Okay, let's go back to the slides. We just saw this demo code. Okay, now let's talk about the map. Map is also another associative container, which stored set of ordered pairs. The first is a key, and the second is the value that maps to the key. And there's no two mapped values with the same key values. So key is a unique value. In this example, string value will be used as a key, and the key will be mapped with the int type of the value. When you use a map, you can use a square bracket notation to access elements in the map. Using this square brackets notation, you can store and retrieve elements stored in the map container. And the elements are sorted. The map container, the elements are sorted just like a set. Okay, so let's look at the demo code for the map container. Okay, this is the output. Let me bring this. This is the output of this program. Let's look at this program one by one. Here we are declaring the map container. The first and second elements are both string values. And we said that we can store the elements using a square bracket notation. So using these square bracket notations, we are storing 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So this line will be same as, will be stored as Mercury and hot planet. So this one will store this pair of the elements where Mercury is a key and hot planet is a data values mapped to this key. And same for other part as well. And here entry for Mercury, and we are obtaining the data values which are mapped to this Mercury key, which should be hot planet. So that is the reason why the program prints hot planet here. This line maps to here. And now this time we are using a find member functions to check whether Mercury key exists in this container. And because there is a Mercury, the program should print this line. Yes, the program prints this line here. For this one, we check whether this Sarah's key is in this container, but because there is no Sarah's in, we did not edit Sarah's key, so this one should be printed. So this one printed as expected. Now we are iterating all the elements in the map container. So you're using an iterator. So this is the type of the iterator. The type is different. to compare to the iterator used for the vector list and set, we learned that all the container has its own iterator type. So this is the map containers iterator type. And just like other example from vector list set, we use a begin, end, and increment member functions to iterate all the elements stored in the container. So that is the reason why we said that iterator provides the consistent interface. And this time we are accessing the key value. The first, we said that this map stores the pair of the value. The first one is a key, second one is a data. So we can access the key using this first, and data that maps to this key using this second. So that is the reason why it prints here. It prints all the keys and data. And they are sorted based on the key here. Note that we added mercy first, but it prints earth first because E is smaller than M. The elements are sorted based on the key value. So that's it. This is how we use a map. And don't forget that in order to use a map container, you have to include the map library and you have to specify the namespace std. So instead of writing this 4-line, you can just using namespace std. And if you write this one, you can remove this line. But it is better to specify necessary namespace here, because if you do this, you include all the namespace defined in std. So unnecessary resources will be included here. So it's better to explicitly specify only required resources here. Okay, let's go back to the slides. So this is the demo code we run in the terminal. So let me summarize this week's lecture. So first of all, we learned how to use our vector template classes. And we learned the standard template library, the STL. We learned that STL is a set of C++ template class. Using STL, we can write code quickly, we can write efficient code, and we can do the generic programming. And there are 4 key components in this STL: container, iterator, adapters, and algorithms. We talk more about the iterator and container components in this week's lectures. Iterator, there are 3 different kinds of iterator: fold iterator, bidirectional iterator, and random access iterator. And these 3 iterator can further categorize into the mutable and constant iterator. That's depending on whether you can change the value of the element using a dereferencing operators. If you can change it, that iterator is immutable. If not, the iterator is a constant iterators. And we also learned the reverse iterators. We can use a reverse iterator to access elements from the last to the first one. And for that case, we use our R begin and R end. So don't make mistake. And we also learned container. We learned that there are two kinds of containers: sequential container and associative container. That's it for this week's lectures. See you in the next week.